Good afternoon, everyone. I am Kriti Bharti. I am the Senior Product Manager for AWS IoT. Today, I'm going to be talking about the AWS IoT portfolio, especially in context of IoT security. I will also provide an overview of AWS IoT Device Defender, a new IoT security service, and then we will dive into 2 customer use cases. AWS IoT has a suite of services, both on the device as well as the cloud side, that help our customers manage their IoT workloads more effectively and more efficiently. AWS Greengrass and Amazon Free RTOS are our edge-based softwares that help our customers connect their assets securely, gather data, and take intelligent remote actions, even in the absence of internet connectivity. On the cloud side, we have AWS IoT Core, AWS IoT Device Management, and AWS IoT Analytics. AWS IoT Core helps customers securely connect their IoT devices to IoT Core, as well as other devices, and then route and process the data collected from these devices. AWS IoT Device Management helps our customer quickly and easily onboard and manage diverse and large fleet of IoT devices. Customers use AWS IoT Analytics to reason on top of their IoT data. At reInvent last year, we also announced a new security service called AWS IoT Device Defender. Today, I'm pleased to inform you that AWS IoT Device Defender is now generally available. Security is, and always has been, a top priority at AWS. AWS IoT customers use standard security mechanisms to connect their devices to AWS IoT Core. These mechanisms are well known, well understood, and well vetted. For example, we support X509 certificates for managing device identity. We use the strongest encryption protocols, such as TLS 1.2. But our customers were still concerned about building secure IoT applications, because security is dynamic. What is secure today may not be secure tomorrow. Our customers told us that they needed a mechanism to detect compromise when it has occurred, be notified when a compromise has occurred in a timely fashion, and most importantly, use a mechanism that can evolve with the evolving threat landscape. AWS IoT Device Defender helps our customers meet their security objectives for building secure IoT applications. We have a feature called Audit. Customers use Audit to make sure the IoT configurations associated with the resources for their IoT devices are configured securely. Insecure configurations has been a leading cause of security incidents. For example, Mirai botnet used the default user ID combination to launch a DDoS attack. Audit informs customers if their IoT configuration is in violation of the recommended security best practices. We also have a feature called Detect that continuously monitors high-value security metrics from the device, as well as on the cloud side, to make sure that they are not acting unexpectedly. IoT devices are usually single-purpose devices, and their behavior is well understood. So any deviation from these defined or expected behaviors is a cause for concern. Customers receive an alert if any potential issue is identified either in Audit or Detect, and they're able to investigate and mitigate these issues. Let's dig into these features a little bit more in detail. Audit acts on IoT resources that are associated with an IoT device, such as IoT policies, X509 certificates, There are a set of checks that are mapped to security best practices to make sure that the customer have configured these IoT resources securely. Customers have the ability to either schedule an audit, for example, a daily, weekly, or a monthly audit, or execute an audit on demand as per their need. It's really, really easy to use. Let me show you how. Customers will navigate to the Defend menu in the left navigation bar in the AWS IoT Management console. Click on Audit. They are able to see any schedules or audit schedules that they have set up in the Schedules menu, or be able to create a new audit using the Create button. This brings up a list of all the audit checks that are available to the customer. For my demo, I selected the check for overly permissive IoT policies. Then I can select how often I want to run the audit and click Create. I am able to see the progress of the audit in the Results menu. I can dig into these details. I can click on the audit, and that brings up all the details associated with that audit check, including the details on the non-compliant resources, as well as the steps that the customers need to take to fix the issue. It's really as simple as that. With just a few clicks, you can get started with audit. We also have a feature called Detect. Detect monitors both the cloud-side and device-side security metrics. And any devices that violate the behavior associated with these metrics can be investigated. Customers define these behaviors in the console or using our APIs. The device reports these metrics to AWS IoT, and these metric data points are compared to the behavior that is defined by the customers. If there is any non-compliance with the expected or defined behaviors, the customers are alerted. Customers can group their behaviors into what we call a security profile, which can be attached to either a group of devices or to the customer's AWS account that will apply to all the devices in that account for ease of management. I'd like to call on stage Franz Korsamky. He is the CTO of Rachio, a company that manufactures smart sprinkler controller systems. Rachio built a proof of concept for using cloud-side metrics in Detect. Franz?
Thank you. Thank you, Kriti, for that introduction. Who is Rachio? So we're a Colorado-based IoT company. The company was actually founded at about 5 years ago at a 48-hour hackathon. The other co-founder was with the group. They were looking for a problem. Colorado was in a serious drought, and he was walking around the neighborhood, I think walking his dog for some inspiration, and it had started to rain, and all the sprinklers had started, and voila, kind of there's the idea of invention, and then 5 years later, we have a smart sprinkler controller. Proud to say we're 100% designed and manufactured in Colorado. So our printed circuit boards are built in Loveland. All our plastics are built in Aurora. All the software is built in Denver. And then all the assembly and shipping is also done in Loveland. So really proud to have 100% designed and built product there. Right around 50 employees now. We're in downtown Denver. And our mission is to make sustainable water use effortless and personally rewarding. So what's the problem here? The current state of irrigation, there's about 1.4 trillion gallons of waste each year, and that's almost 60% of residential water waste is due to that. And that's a pretty big cost to homeowners. It's about $2 billion, so really big problem. And where does all that problem come from? Well, it's typically that thing hanging on the wall. There's no real-time weather, so we call them dumb timers, where if it's raining or snowing or it's hotter out or cooler out, there's no adjustment. Currently, what customers will do is they'll set up the controller in the spring. We call it set and forget, and then in the wintertime, they'll turn it off. So there's no adjustment. Typically in the spring, it's cooler, and in the hotter months, the controller runs kind of exactly how they set it for the cooler times. There's no data from these controllers, so right now they're in about 20, 25 million households, and all the data about people's yards, their water usage patterns, the water usage, the scheduling, all that data is kind of built into that thing with no access to it. And then really, they've been built for professionals, so you kind of need a PhD in irrigation in order to set them. If you kind of remember the VCRs back in the day, you kind of almost had to be a professional to be able to set those and get them kind of tuned in. Just for, who here has actually a yard? Okay, good, because I've done some of these talks, and it's really hard for people to connect to this when they don't really have a product in their house that is doing this. So the solution was building a smart sprinkler controller. Typically, customers will, it's about a 20-minute install process. They'll take the old one off the wall, put in the low voltage wires, connect it to the internet. We ask them some very simple questions as to what type of grass they're growing, what's the soil look like, slope, sun exposure, and from those simple parameters, we can actually adapt to local weather and the seasonal changes. We have access to about 300,000 personal weather stations, so we can deal with any microclimates. And then we have some pretty amazing features where every time, right before your schedule is supposed to run, we'll do a skip check. And if there's a certain amount of precipitation, or the temperature is a certain value, or there's high enough winds, we'll actually skip that schedule for you, or change the frequency of your schedule, or actually change the duration in the minutes. Each week, we do around 150,000 weather skips. That equates to almost 160 million gallons of water we're saving consumers each week. And to date, from the formation of the company, we've saved, I think, close to 32 billion gallons of water. So really proud to have a product that really takes advantage of technology. We're on our third generation of hardware. Generations 2 and 3 were built on the IoT broker. I think we're one of the very first customers in the beta program. So funny story, there was a company called Telemetry that were based in Denver, and they got acquired by Amazon, which is now AWS IoT, and we're currently in that same building. So it's neat to have that kind of legacy there. Our third generation hardware just came out about 2 months ago, and it has 2 types of radios. It has a Wi-Fi radio to connect to the internet. It also has a LoRa radio where we can now have wireless accessories. Our first accessory is a wireless flow meter that allows us to do leak detection, water budgeting, and then get very accurate usage. So at Racho, we take security and monitoring very seriously. We use all of Amazon's recommended best practices from virtual private clouds to private subnets. We're using a web application firewall, CloudWatch for monitoring. So I felt like we had really had a good overall understanding of our infrastructure and ecosystem, except for the parts at the edge, namely these controllers. So Kriti has come to me multiple times with new products and solutions, and I always said, that's great, but what I think we really would love is to have this kind of autonomous, automated device monitoring. And with this new product, we finally have that, and we're really excited to have been part of the beta program. So one of the main cost drivers at Racho is its support, and a lot of that is due to Wi-Fi connectivity. So I thought that for a good proof of concept, good use case would be to identify controllers that are having Wi-Fi connection issues. And it's actually a bigger problem than you think. We have seen every type of Wi-Fi problem out there due to mesh networks, the controller not being close enough to the router, router extenders. So when the controllers are going offline, it's a bad customer experience, as well as we can't provide our cloud intelligence. We can't do schedule skips. We can't do schedule adjustments. So it's a really big problem with us. And typically, what happens is customers will call into our support line and then usually it's going down 2 or 3 tiers so that we can troubleshoot, get the controller back on Wi-Fi. So I thought for a great first use case would be to get some sort of baseline where we know how many messages are typically being received from controllers, how many are being sent, what's the average size, and with that data from my engineering team, we were able to, it was literally in minutes, create a security profile with these behaviors. Now, when the controller would go out of the behavior, we would get a violation alert, and then on the next slide, I'll explain kind of what that life cycle looks like. So the real problem here was trying to identify controllers that had continuous problems connecting to the internet. And we see controllers where they'll connect 500, 1,000 times per day, reconnect and connect. So that right there is a red flag that we should be able to reach out to the customer and give them some troubleshooting tips immediately so they don't have to call into the support team. So for our proof of concept, this is kind of the life cycle of the violation process. So on the left side, you can see our Generation 2 and Generation 3 controllers and connected to the IoT broker. Sitting in the middle now is Device Defender. And we created a group for this proof of concept controllers and attached that group to the security profile. When Device Defender detects the anomalies, you'll have a message that goes right to SNS. And if people have used SNS, it's a really powerful tool where you can connect pretty much all of the Amazon infrastructure. So for this use case, we have the violations going to a Lambda. And in that Lambda, we can actually look up customer information based on the device ID. So when you crack open that payload, it has the violation, it has any extra information for your Amazon, the IoT thing, as well as what the behaviors, how many, kind of the parameters that triggered the violation. Those are all in the payload. So from there, we look up the customer information. We actually programmatically create a ticket through Zendesk. So we use Zendesk for our support. That triggers a custom email to the customer with all the Wi-Fi troubleshooting information, as well as any other kind of data we provide. And that goes to the customer. And that really has helped us with quite a few different controllers in the Wi-Fi troubleshooting parts. So as I mentioned, through the proof of concept, we've seen immediate value. I can't tell you how many customers we've been able to reach out to, automatically provide this troubleshooting, and we've gotten some really positive feedback to have this automated continuous cycle to reach out to them. With any product, I think you can build in some enhancements. So what we did was kind of rough, where we would guess that if a controller had sent, let's say, 500 or 1,000 messages to the broker in one 24-hour period, that for us, that really meant that it was a Wi-Fi connection problem. But it could have been a controller that was compromised, or there was a firmware defect. So I think in the future, one really valuable thing would be more so than just seeing the messages at a high level received and sent, to be able to use some sort of regular expression, crack open that message, look at the message type, and then be able to do counts like that. The other thing I think that would be extremely valuable is I had to work with my engineering team to come up with these, let's call them baselines, right? Where on average, controllers are sending this many messages, we're receiving this, message sizes are this. I think it would be amazing if the tool could come up with a predictive behavior monitoring where they would view our messages, come up with these behaviors, and then I can go in there selectively and say, oh yeah, that's perfect, that looks about right, versus having the engineering team kind of root out that data for us. So I'm really excited to see the service evolution. Like I said, we've been a beta customer IoT since its start, and we've really seen this product evolve, and I'm really excited to be on that journey. Now I'm going to hand it back to Kriti.
Thank you, Franz, for the talk. As I'm sure you all are aware, we use customer feedback to influence 90% of our roadmap, so we thank you and appreciate your feedback. We also work with AWS Partner Network and different partners to integrate AWS IoT Device Defender with our partner solutions. I'd now like to call on stage Ian Marston, CTO of Eseye. Eseye integrated their AnyNet solution with AWS IoT Device Defender to use device-side metrics and detect for our customer SolarNow. Ian?
Thank you, Kriti. So I'm Ian Marsden from Eseye, and Eseye is a service provider and system integrator for cellular connectivity. So we run a global network for managing IoT devices and making sure that they're communicating. We've been working now with AWS for a couple of years, and obviously integrating our solution directly into Amazon itself. We're also a IoT competency partner, and so obviously we were one of the initial competency partners. So we work with our customers to deliver end-to-end solutions and to help them go through their whole IoT journey. And we start on this end with the device. Obviously, the device is critical here. And then we run and provide the global connectivity, utilizing mobile networks, so global network providers, all the way through into Amazon itself in the cloud. And today we're talking about Device Defender, so we add on the top the Device Defender to provide the intelligence into that. So with a partner here, obviously there's a customer called SolarNow behind that, and we're going to take you on a brief journey across to Africa now and let them introduce themselves.
SolarNow is a renewable energy company that began its operations in Uganda in 2011. SolarNow provides both small household systems, which range from 50 watt peak to 200 watt peak, and large home solar systems, which range from 250 to 3 kilowatt. These are both used for domestic and commercial purposes.
SolarNow, in the process of transforming people's lives in Uganda, has now reached to 20,000 homesteads. We've subbed systems to 20,000 homesteads. And these are people who are largely initially off-grid.
So obviously SolarNow is one of our customers, and they are mainly based out of Uganda. And they use the Eseye AnyNet secure product along with AWS to deliver their total solution. Their solution is being sold to people that are off-grid, so homes, farms, schools, businesses, and enabling those to have reliable power in a cost-effective way. So therefore transforming lives and communities. To drive into how we use Defender in a little bit more detail on this. So we're talking about the detect function here. So the detect function is really around monitoring the connectivity, looking at the metrics on the connectivity. The security profiles are defining intended behavior, and that behavior is being monitored to detect violations from the normal behavior. Metrics can be collected from the device itself, or they are metrics like Rachio is using coming out of the IoT service itself, but they also can be generated by the network. So, and this is what SolarNow is using. Eseye, as the network provider, are providing metrics on behalf of the device into the IoT core. And this has an advantage to some customers in the fact that we can create these metrics without having to upgrade the device. So there's not necessarily, we can retrofit it to existing estates, And so we can enable it on legacy devices or even just devices with not very much resources, so very resource-limited devices. So in this diagram, you can see the devices out in the field. Because we're providing the managed network, we can provide the metrics out the side into Device Defender. And the piece on the right-hand side is actually an example of the network metrics that are being provided. So let's have a look at the architecture of SolarNow. On this left-hand side, you can see the devices themselves, as I said, communicating over the AnyNet secure managed network into IoT Core. They're using the Eseye marketplace integration, which allows the subscription management of the cellular device to be managed from within the AWS IoT console. So there's no separate integration that the customer has to do. It's being managed by the marketplace integration. On the right-hand side, I didn't go into all the detail on it, but you can see they have a sort of typical, fairly complex IoT type application. And obviously what they wanted to do was enable Device Defender and the detect function particularly to raise alerts around devices that are behaving abnormally. So what did we do to do that? So we enabled Device Defender on the estate. Obviously, we're looking at defining the security profiles that are relevant to these devices. As we've seen earlier, this creates notifications on SNS. And for SolarNow, we wanted to create 2 levels of notifications. Sort of low-level alerts that a customer services team would want to look at. That's an email-type notification into a ticketing system or the like. But also potentially there's sort of critical alerts that are going on that you don't want to wait for a customer services team to wake up to. And that's where we tied the SNS back in through the Lambda functions into the marketplace integration. And this allowed us to automatically suspend the SIM card in this example if a critical violation was detected. So you can see us closing the loop between detecting the security threat and actually managing it. And you can obviously see where this can go in the future. So for us to define the security profiles, we kind of first needed to understand normal behavior. It was mentioned earlier, this is the first step of this. So to do this, we ran metric collection on the SolarNow estate for a few weeks, and we then analyzed those metrics to try and work out what normal behavior looked like. And therefore, we could define the violations to obviously trigger the control loops. So there's a number of metrics that Device Defender allows you to look at, and one of those defenders is, metrics is bytes in and bytes out. So on the left-hand side, we started by looking at the number of bytes in, bytes out for the whole estate. And it's a very pretty graph. It doesn't actually give you a security threat. It just shows you that there's some cyclic behavior of solar lighting systems. However, one of the nice features about Device Defender is, of course, that it allows you to drill down into the device level. So sure enough, if we look on the right-hand side, this is an individual device out of this set, and it was quite happily going along normal behavior. And then on a certain date, it started using an awful lot more data. This, because Device Defender is looking at the individual device, allows us to pick that scenario up and act upon it accordingly. So obviously, this was a metric or a violation that we decided we would want to just raise to customer services because something's wrong, whether it's a misconfiguration or whatnot. So another metric we looked at that Device Defender allows you to use is the destination IP analysis. So as where's this talking to? And so in this example, we looked at the destination IPs that were being used across the estate and said, do we know what all these destinations are and do they make sense? So we can see at the top we've got the DNS server that's being looked at regularly, and then you can see there's a whole load of IoT endpoints. Obviously it's load balanced that these devices are talking to. And in this example, this is one device spread across time, and you can see that we managed to get a violation where it started talking to an IP address that we hadn't recognized, hadn't seen before. Whether, again, was it meant to be, had AWS added a new IP address? Maybe, but we needed to detect that. And this is potentially a security threat that's significant enough that we decided that we wanted to caused this device to be quarantined. If we started seeing a device that was communicating to an endpoint that we didn't expect, then this is potentially a significant risk. So we now go on to actually setting up security profiles within the detect function under Device Defender. So I'll walk you through the scenario we did. We decided we wanted two security profiles, the suspend profile and the alert profile. So we started by creating the SolarNow suspend profile, and we said the suspend profile would be based upon destination IPs. So we select the number of the IPs, and I've just pasted in the list of acceptable IPs to this. Obviously, we then trigger the SNS queue message for the behavior, and in this example, we have a SNS topic called SolarNow suspend. As mentioned earlier, you can apply a security profile to a group of things, or all things, and in this example, we just attached it to all things in the account, so every device in the estate. So that's the suspend security profile configured. It was that easy. And we then go on to putting the alert profile in, so SolarNow alert. And this time we're going to do it on bytes in and bytes out. So we're setting up the first behavior on bytes in. Obviously, we're setting what is a normal behavior threshold. And because bytes are time-limited, a time series, we actually have to set a duration. And the time duration on the metrics is 10 minutes, so we set the duration on the behavior to be 10 minutes as well. We then do exactly the same for bytes out. That's a separate metric within Device Defender. So we defined two behaviors within the same security profile. Add that. Now this time we're going to point it to the SNS topic of alerts. And again, we'll apply it to every device on the fleet. And that's it. That's our two security profiles now set up for the estate. Now, when we looked at the architecture, you saw I said we could use the alerts to create into SNS to create an email into customer services, which is really super easy to do from SNS. But also I wanted on the suspend option to actually be able to automatically suspend the device. So in this example, we set up the SNS topic, and we're here setting up the suspend topic, so the one you saw us configure in the security profile just now. And this time we're going to want to attach to that SNS topic the custom Lambda functions. So as part of the Eseye AnyNet secure functionality, we provide a number of Lambda functions that help manage your cellular estate. And in this example, there's a Device Defender Lambda function that deals with suspending and restoring a SIM card. And all we do here is we link the Device Defender notification Lambda onto the SNS topic such that the SIM card can be automatically suspended when a violation occurs. So you can see that there. We configure the trigger to be the suspend SNS topic, and then we add that. And that's it. So we've seen how we set up the security profile, alert, suspend. We link that so we can close the loop on the control management on it. And now it's running. So what we want to look at next is obviously, what does it look like when it goes wrong? When something happens? So a violation occurs. And so I'm going to look at some violations. You can see what happens. So again, on the defend menu item, we go to the detect function, and you can see there's an item there called violations. So we go down to violations. I've got a device in violation here that's actually triggered both the alert and the suspend functions. And you can see, if we drill down into it, what actually happened, when it happened, what the violation itself was. Because we triggered a suspend violation, we would now expect to see the SIM card in this device to have been suspended. And you can see this in the shadow state. There's an AnyNet shadow state here, and the status in there is now being reflected as suspended. So this device is now quarantined, isolated from the network, send an alert into customer services to say, go and look into this device, find out what's going on, but protect the rest of the fleet. So that's a quick walkthrough, really, on Device Defender in a real-life scenario. Hundreds of devices, thousands of devices in Uganda and the rest of sub-Saharan Africa. But Device Defender and AnyNet and SolarNow, obviously, we provide the functionality to connect and secure their fleet. It's very simple to set up those security profiles, detect abnormal behavior, and trigger different business logic on the back of it, obviously dependent on the violation and dependent on the application itself. Device Defender easily identifies situations from misconfiguration all the way through to potentially misuse. And therefore, we're protecting the customer's brand, SolarNow in this example, and kind of more importantly, in some ways, their business model. And transverse that onwards in SolarNow's example, where we're powering things like vaccine fridges in remote health centers or farmers' irrigation systems. We're really managing and protecting those livelihoods and even potentially lives out there in the real world. So really, Device Defender provides a really simple way to add security management on top of what is an AWS IoT-based integration and a deployment at a fleet level. So that's me. I'm going to hand back to Kriti, and she'll tell you a bit more.
Thanks, Ian, for showing how easy it is to get started with IoT Device Defender. So as Ian and Franz talked about it, AWS IoT Device Defender sends you alerts whenever we identify any issues either with your IoT devices in Detect or with your configuration in Audit. These alerts are available on the IoT console, but we're also integrated with Amazon CloudWatch and Amazon SNS. Integrating with Amazon CloudWatch gives our customers the freedom to continue to use the SIEM systems that they're already using. For example, Splunk is integrated with CloudWatch logs. So customers have a seamless transition to use the SIEM systems that they're using. As Franz mentioned, Amazon SNS is very powerful. It allows our customers to integrate with the whole family of AWS services, including any device management function that they might be using, such as the device jobs feature of AWS IoT Device Management, to take remote operations, remote actions on their devices, such as pushing a security fix, rebooting the device, resetting it to a factory default setting, etc. AWS IoT Device Defender also provides contextual, historical information about the violations or the security issues that we have identified for both audit findings as well as detect violations. For example, if you had an audit violation for an X509 certificate being shared by many devices, Device Defender will provide you the certificate ID, the device ID, as well as the steps that you will need to take to fix the issue. For Detect, customers will be able to view a historical representation of whenever their device has violated the defined behavior, or if they have come out of violation back into compliance with the device behavior. AWS IoT services work independently, but we also work better together. AWS IoT Device Defender is also fully integrated with both our edge-based softwares, AWS Greengrass and Amazon FreeRTOS. So both our Greengrass and FreeRTOS customers can use AWS IoT Device Defender, both audit and detect features, with just a few clicks in the console. At this point, I'd like to open it up to any questions that you might have for me. Say that one more time. What do you mean by a positive and a negative security model? So today, it has to be all the IP addresses that you have to provide. Sorry, you mean to say, will we do a backfill of the data?
Right. Can we see the history of devices that were in the field before this became generally available?
No, you wouldn't be able to do a historical view before our GA, but since now we are generally available, you will have a historical view of any violations going forward. Any other questions? Well, I hope you have enjoyed the session. Please feel free. I'll be standing here on the side if you have any questions that you'd like to ask me. Thank you.